call it machine learning, we call it AI. Keep changing the name, but at the heart, we are, using thousands of years using math to do better things, and what you're doing today is super exciting. I'm excited to be here with two great panels.
Oh, thank you. Can we go? Okay, hi. Dr. Jeff Esposito, multiple PhDs. Just call me Jeff or Espo, right? Just as regular as they go. 40 patent submissions in the past 5 months for AI. I run the engineering practice at Lenovo for R&D AI, and I'm a very positive futurist. I believe that as we imagine it, so can we create it. And through that imagination and that shared collaborative imagination, we create something greater than our own particular perspectives. So I'm not sitting here to say I'm Pollyanna and I believe that everything will just be wonderful. But together, I think we can build a pretty nice future.
You'll hear this over and over. He's such a sweetheart.
Thanks for.
So, hi everyone. I'm Pearl Almeida. I worked in cybersecurity, but way before that, I actually started working in AI regulation, and this was 8 years ago with the Canadian government. So it kind of just shows how things are kind of picking up and people start caring when they need to be reactive, and unfortunately that's how cyber is as well. I know that I haven't seen much talk about security at this conference, and especially when we're talking about AI, like software and hardware, security should be at the heart of it, and so that's a bit of my passion project. Here to evangelize where I can, but yeah, let's get started. I mean, when we think about AI infrastructure especially, there's so many news articles that have come out even in the past week related to hardware specifically. So I know that last week, Torrent had advertised that they got nearly $700 million of funding, and this is a chip company where they're talking about open source software and really aiming for interoperability, and that's a big change that can really open doors for a lot of companies that can't afford NVIDIA. And then there's also some stuff with Amazon. They had released a new chip, the Trainium 2, lots of processing power, quadruple performance. So how are we feeling about all of these news headlines that are coming out, and what does that mean for the future of AI that we're currently building?
Well, I think this is great in terms of innovation and the way that companies are moving ahead. It actually provides a lot more access to many individuals and small companies that don't have the funding that's available for these generative AIs, right? I think that it's going to be great for the general public too, because it will create a lot more competition with NVIDIA, because NVIDIA is the leading GPU right now in the market, and it will lower costs actually. So this is going to be very exciting in terms of how much more innovations that it can produce, because when you give access to many more population, you can expect to have more innovations and efforts in terms of the space in the very near future. So I'm very excited about it.
So I think about computation as the heart of what we're doing, right? Everything that is happening today is because of computation. So the idea of me talking to computers like today, like in the language models, is not new. We always wanted that. Right? If you go back 40 years ago, there are papers on that, there are even products around building that. Has been, but really what we didn't have was computation, simple. Right? So now we have computation. The cost of computation, if you think about like in terms of gigaflop, right? It used to be 10, 15 years ago about $100 per gigaflop, per teraflop, and now it's about 1 cent. So what's really happened is the prices dropped, and now we can build this gigantic system. Right? And I truly believe we are not smarter than the people from 15 years ago or 40 years ago who were trying to build this interaction. But what we have data and computation. So what's happening is really great, because now with this acceleration, we're going to have more and more computation, and it's going to be cheaper and cheaper. And the interesting part is about this, because what's really happened in the last few years, which make AI everyone is like excited about, is language model, how we interact with language, right? But language is the very simplest forms of sequence. Right? If you think about like as everything in the world, we invented language to have the very characters, very super structured way. But when it goes to everything else in the world, like voice, vision, movement, they are much harder to model. And how much computation we have today, it's really not enough to address those problems. It doesn't matter how smart you are, how algorithm, what kind of algorithm you have. The computation is not there. So, and I'm very excited to see that we have this computation coming up, and then we can attack those problems. Especially, like one thing I'm particularly very keen on to see what's going to happen, especially probably I would say 5 years when you have 10x or 100x more computation. What's going to happen around understanding on genes and especially like drug discovery, which is one of the very complex mathematical or even computational complex problem, and it's still, we are starting to reach to the point that slowly get to the point that we have enough computation to do something with it. But I think having 100 times cheaper computation would be game changer.
I was going to say, I think you both make excellent points because you're talking about enabling real competition, and competition drives innovation, right? So it's always a question of reaching for the best. And I think your points about computation are very true. And I think in the best situation, improvements in chips and improvements in hardware technology, it simply enables and gives us the choice of how efficient we become and how we address the different challenges, right? So as the hardware increases, our potential applications increase in proportion to that, not always linearly, and not even always in any kind of reliable measure. But one of the beautiful things at Lenovo is that we embrace these kinds of environments, and that we're always working to integrate and extend our hardware technologies to open up as many doors as possible for us. So I think it's a very exciting thing. I think you both bring up excellent, valid points about competition and computation, which sound a little bit alike, don't they? Competition and computation. But I think that really hardware enables and software follows behind. And it doesn't always follow behind effectively and efficiently. So the challenge to us, as all of us in the room, as futurists, is to envision options and applications that open the door to a future we want to have.
I like this idea that we're talking about, like, almost creativity, because even Davood, the point that you said that we're not really smarter now.
No.
It's just the technology is enabling us to really expand the way that we think about solving certain problems that we're experiencing right now. And there's different ways of going about it. There's different tooling, and that's just going to keep increasing across different applications, different industries. You know, like I'm sure, like with you, Joe, he teaches a capstone course where he's interfacing with a lot of students that are working on problems from various different industries, and I'm sure like he sees a lot of that creativity applied in different ways.
Well, most definitely. I mean, the capstone projects that we lead is working with particular clients to enable their somewhat what I call proof of value, right? Essentially, making sure that they're adding value to the organizations. And then using these technologies, essentially Gen AI, I said, go ahead and have fun with them, right? And then use it to the best extent. And then they're coming up with creative solutions and never thought of before, and then there's really adding value in terms of the clients, and then they're moving ahead with it. This is very interesting in terms of that.
So I want to actually continue what you
Yeah,
said,
go
Joe,
ahead.
is there's a book called Where Do Good Ideas Come From? Have you read it? Anyone read the book? So
where do good ideas come from?
I'd
love to hear.
Summarize it.
Right. That's I read the book multiple times.
You read the book?
Multiple times to understand where does that come from? What's happening? So Steve Johnson wrote the book, and it talks about that. It's a long book. I'm not going to summarize it here.
We've only got like half an hour.
Just ask ChatGPT. But
I hope it's right.
one point which really got my attention when I was reading the book is usually you see a lot of good ideas is coming from grabbing two old ideas and putting together. Right?
Oh, interesting.
It's like there is this idea, very interesting idea in this domain. There's other interesting idea in this domain. Putting it together, I was like, oh wow, I can do something great here that we couldn't do before. So that happens all the time. You just go and read the research paper, right? Barely someone invents something new. resolve like, oh, this idea works here really good. Well, how would I apply it here? So, but this process today is a very manual process. It was a human-based process. I go as a researcher, I look at this idea here, I look at this idea here, I was like, maybe they work together. I test it out, so sometimes it works, sometimes it doesn't work. But imagine a world that machines can do it. Machines can look at the different ideas, at different domains, and put them together. They can do a lot more than us, right? And they are faster than us. So that's why I think just the whole innovation is going to be exponential, just because now machines can put ideas next to each other.
So Davood, let me ask you a question, because I think that's very interesting.
Yeah.
That's very interesting, because I think we're all almost talking about permutations and combinations of ideas to create new approaches. So we have invention that I think comes from humans with a capital I, and then we have innovation, which is really permutations and combinations of those ideas together. So what you're suggesting is that machine technology itself can help us, at least with innovation lowercase I, so that we can discover more relevant applications. And that brings us back to Joe's wonderful point about proof of value, right? Because everybody loves tech for tech in this room, but ultimately it's about the relevance to the world, the relevance to society. So when you talk about the idea of accelerated innovation, it's still going to need us, because that's where the capital letter I comes from.
So yes, I agree with you. I agree with you, but I can Steve Johnson, he doesn't agree.
Get it.
I do agree with you. But so what I'm thinking, and he suggests that I think in one of his TED talks, he says that like the chance of you coming up with new ideas is almost zero. Just what you can do, just go and look at other people's ideas and see which one you can do better than them. Just because the chance is so slow, right? So maybe that's like what happened. You're right, but maybe gonna happen is this those kind of innovation, by combining ideas, it's not gonna be our job anymore. But making those big ideas gonna be still as an argument as a human.
Wait, can you clarify? So then we're not having novel thoughts at all when it comes to innovation? Or
Barely.
barely?
Okay. Just I'm a mathematician. I always
Yeah, you're the
I
expert.
think Jeff, I can put it in a good sense where he talks about having a capital I of invention, right? And then the lowercase I of innovation. So I agree that maybe we have a narrow definition of invention, but then we have a huge scape of innovation, because the applicability of these new technologies is new, right? And it's going to be innovative in terms of how we proceed with each of these applications. So I think there's going to be a lot more innovation, maybe not as much.
Innovation capital I or lower? That's the question.
Well, maybe it's about acknowledging our sources, and I think that's what you're talking about here, is acknowledging the sources. So if we take one example of a relatively new idea, the Hive transformer model, okay? That's arguably very original, but it actually comes from and stems from ideas already present in the world. So when we talk about a Hive transformer, we are talking about a transformer model, but we really need to understand it well. We need to talk about bees, and what do bees do? They make two things, little bees and honey. Where do they do it? In the hive. Where do they store it? In honeycombs, these beautiful, symmetrical, mathematical, reproducing storage areas. So how do the bees know that the nectar becomes honey? A hive mind index. So here we have a very original, or at least that's what the United States government says, patent pending, is a new idea, okay, which is good enough for this guy, okay? But to the points being made here, is that it really isn't like, it's more discovered than it is created.
Right.
Is that what we're talking about?
Yeah, I
so.
like that idea of, because like we talk about like there's so much artistry in what you said, and like the way that we innovate, like we are just creatures of nature, and when we're learning about how bees are doing things and applying our technology through those principles, it's just an extension of nature. And I love that we're getting into like a philosophical conversation.
We
about
certainly
this.
are.
Yeah, because I think it really begs the question then, like how is this technology really going to impact our culture, like workplace culture, culture as humanity, because we're already seeing massive changes in the workplace. People are asking questions about like workforce displacement, which I don't necessarily believe is happening, but that's another point. But yeah, how do you?
Let me actually talk about this. This is my favorite topic. So, so I love this one. Because
Go for it.
It's not about like replacing people. It's all about like how we change, right? I think so. What's happening today, right? We might not be there right now as of today, but maybe in the next 2 years, we definitely will get there. Is a machine started to understand our language. That's a very important point. Right? I think people say it's like an invention of electricity. I would say it's like an invention of writing. So this is very, very important. Before today, our job, like there are ocean of information there. There's tons of information. It's our job to go and get that data, analyze it, and get something out of it. But imagine very soon, even today, machine can do a better job of understanding data, gathering information, and then putting this together, right? So, and I want to go back and ask one fundamental question from our panelists. This is why I'm going to ask questions.
Yeah.
So, we as a human, right, building organizations and like joining organizations, like this organization can be religious one, can be like, or like companies or non-profits or whatever, right? It has been core to our existence. That's how we started, civilization started. And it's all about language. The reason that we can build an organization because we have language, right? And language is binding. But now machines can understand our language. It will fundamentally change what we call an organization. Because now, lots of skills that it used to be just for humans, now machine can do it. And I want to get your idea. What do you think of what's going to happen? Now machines can be center of an organization.
Before Pearl gets into that, I just want to speak a moment to the idea of how language and thought are inexorably linked. And linguists such as Noam Chomsky and Yuri Nedela did an awful lot of solid research in how language forms how we view things. So language not only binds ideas, but it can limit ideas and definitions. So I just wanted to point out that language affects how we think, and if we're going to postulate that machines will have a capacity to understand our language, then we're asking them to accept common orientations for meaning that they may have no basis of.
And this is a good building point because if we're talking about like what is the definition of an organization and how that's going to change, how do we really define organizations right now? There are people, their tools, their processes, their technology. Like I consider all of that as part of an organization, not just the human aspect, even though that's really important.
It's so important.
Yeah, but so I think about this, right? Your computer, your iPad, your iPhone has an operating system, right? Our organization, they have an operating system with a manual operating system. But soon you're gonna have a true operating system for organization. Like, it's a very, just thinking about it, we are trying to manage those operating systems, like in an old way, by still like if you're using like tools like Docker, Confluence, all those tools, they're not operating system. The operating system is still human and try to manually run it. But I think very soon, at the heart of any organization, there will be an LLM, which is the operating system for the organization.
I look at an organization as more financial, I would say. I separate them.
Yes.
I separate it as an asset and a liability, right? In terms of assets, resources or humans is a huge employees or a huge cost, right? In terms of assets, but I think it's going to change. It's going to decrease a lot of the human resources or human in the organization, and it's going to change into more of a automated solution where it's more AI agents, so to speak.
This is an interesting point, and may I suggest that we take a moment to step back to the practical example right now and the technology that does exist right now, not to be bang that old drum again, a hive transformer. So within these honeycombs, within these hives, we have the capacity to organize data, purposefully pre-curate the assignment of data, which is a very powerful tool. Because if you can assign individual skills to each of these hive transformer models that become a hive, then those skills can aggregate into talents. And going back to Joseph's point, those talents can aggregate into persona. And when we have persona, we now have virtualized roles, right? So as it stands right now with technology in our grasp, at this moment at Lenovo, we literally have the capacity to generate interaction and a shift of complex skills and technologies based upon NLP interaction. So if someone's out of nowhere speaks to a chatbot or an avatar, its apparent focus is diagnosing and setting up an SR670 class server, edge server, and says, I'd really like to know something about the Think Edge laptop. Well, that, by definition, is outside that persona. But what we do is we capture that moment through NLP keywords, right? We go and we switch the hive. We switch to a different hive. And so now, to Joe's point about persona, I think what we really need to do to understand organization is to make sure we come up with an effective definition of persona and role. And so therefore, I tend to see it as a very positive thing. Not so much that, oh, we're going to lose our jobs to the bots. I see it as we will be freed, a Star Trek Next Generation kind of thing. I prefer to see the glass isn't shattered and broken or even half empty. It's an opportunity for us to pursue deeper passions.
But Jeff, actually, you brought up a very interesting point when you mentioned 5 minutes ago. I don't know, like 5 minutes ago. And then you mentioned like when we think, and language is some of the beginnings in how we think, right? So that's it. But now I'm thinking including the context of language models, because like the LLMs are just written based on what we write.
Yes, language models.
So they're not actually representing our thoughts. And I guess the biggest question is how we can build a model that will represent our thoughts, not represent our language. So
it's interesting because now we're talking about something more towards, thank you, Nicole. We're talking about something that's more towards neural networks, the idea of the nodes, don't you think, Joe?
Yeah, so the whole idea of neuromorphic chips is the basis of mapping out how the brain thinks, right? And then putting it into an application where it uses very little energy. So it is a very key technology as to creating the next future of tech, right? In terms of wearables and the various kinds of things.
I was just going to say, I'm told very often I don't use much energy when I think. I don't know if that makes me next gen. That's a nice way of saying he doesn't think enough.
He's the best.
Yeah, I think it's interesting. I feel like I hate that we're so focused on neuromorphic computing and technologies because we're so focused on what we understand, which is ourselves. You know, like everything has to be a recreation of how our brains work and how our synapses fire. But there's so much more, and I'm sure there's other models which you've already talked about. And we're so, even like with the robo-dog, we were talking about how, you know, you want to call it, like
You want to treat it like a dog.
yeah, I do want to treat it like the dog. I saw him, I was like, can I pet that dog? Like,
Sit.
yeah, and even when I was talking to one of the scientists that was programming it, they had said that when they're walking the dog or taking the dog out, people will say, oh, what's his name? So it's interesting because then there's also the gendered element so that they put a they, them sticker on it. But it's interesting, it speaks to like language and how we kind of view ourselves and the environment that we interface with and how that's just the starting point.
That's beautiful, and that brings me to the thought of robo-psychology, right? And by robo-psychology, I don't mean that we're going to have the singularity. I don't mean that the things are sentient. I'm much more interested about human beings, how they perceive and how they interact, and as Pearl just said so well, how we put stickers on things so that we can handle it. So I think that there's a whole field of study in there that must co-develop with our hardware and our software to truly understand how people interact with the technologies that are kind of mirrors and hopefully simulations and simulacrums of ourselves.
So I'm going to touch on that because I have a story to share on that.
Oh, tell the story.
I have a story to share on. It's not a story experiment, it's a very interesting experiment. So 5-6 years ago, I can talk about it now because it's not my current or my previous employers. Many employers had lots of
It's a hypothetical employer.
Yeah, yeah. I mean, it's like many years ago. It's definitely not the current or passing. We did an experiment on in understanding how can a bot manipulate a person? Like how can I manipulate you? That was the idea, right? And the goal was purely manipulation. I want to convince you to buy this product.
The term singularity can have different meanings depending on.
And that's true.
Yeah.
And that's a very valid answer. This idea of manipulating bots.
Yeah, really good. So what we did, we had an experiment and trying to say, you know what, it was pretending to be wine recommendation app, but it was just trying to convince you buy expensive wine. But that was the goal, right? And the way it was working, it was taking picture of you, like it was running experiment of you, taking picture of you, sometimes telling you you look like a celebrity, trying to give you a lot of good compliments, then try to have a conversation with you around with how much there's a correlation between having aging and this other concept, and then keep trying different sentences and asking you that, convincing you toward that if you pay more, probably get a high quality, probably very happier. So,
interesting.
And the end of this app, before doing it, was only we're asking you, now tell us, I want to recommend you, because it was a wine recommendation, which price range do you want? Like you want it like on the 20 to 50, 100 plus. And we just put the reinforcement learning behind that to say, no, your goal is to maximize this price. Your task to play a role that is 100 plus. And it was
interesting.
And what is, my expectation was it's not going to work. That was my expectation. I was like,
It's a reasonable expectation.
I was like, people are not going to believe
People aren't going to buy this.
Right?
But yet they did.
I was shocked how much people believe in it. I was like, wow. Like one of the sentences was that, like, we were telling everyone, you are stressed. Based on the picture. You're taking a picture of everyone, right? We tell you find your celebrity close to it, and we're also saying, based on your picture and face, you are stressed. And everyone find a reason to feel stressed. Like, and they was like, yeah. It was like,
It's the corner end. Yes.
I mean, there's so much like behavioral psychology to what you're talking about. Like even in cybersecurity, like everything is capitalizing on your current way of being, how you're feeling in that moment, and that's how you get tricked into doing things. And like we're so susceptible to manipulation, and we think we're so much bigger than that, but we're really not. Like people fall for cults all the time and don't even realize that they're part of cults. You know, I'm sure that there are some companies that feel like a cult, especially when there's big founders. You know, but technology does this.
This perfect example recently with like a hurricane. Anyone seen the picture with the little girl in the boat with a dog in the news? So it is really surprising because when this picture came out, everyone was very sad about it, believing it. But then when individuals pointed out that this was actually AI generated, people didn't care. That was a surprising point. There's, it could have happened, right? And that's the change in terms of sentimental values with AI and the believability, and people want to believe that that's happening. And then it's tapping into their feelings, and this is something that can't really be measured now, but then I think that in the future with everything that's being mapped out, maybe in the future.
Yeah, I mean, if we're, like, to add on to this point, something that I've noticed at this conference especially, we talk about like business cases. A lot of companies I'm seeing don't really understand where they want to use AI, where it could be used efficiently, and they come up to any and all vendors saying like, this is kind of what we do, and I find that the vendors are just prescribing their tools onto them because they're making the sale. Because every business leader, especially IT leaders, they really want to be on the edge of innovation, and they don't want to fall behind, and they're almost like falling into traps where they're signing on contracts with tools that may or may not be helpful, and if they don't understand their business case and what efficiencies they're actually trying to drive, what KPIs they're trying to hit, create an entire POC to understand what they need out of it, and maybe see like where the tool is actually supplementing and helping in other aspects of their business. Like they're not seeing the full picture, and so in a way, I feel like people are very open to manipulation at this time.
And the other half of that apple, and I think it's an excellent point you made, Will, is that if all you have is a hammer, the whole world looks like a nail, right? And this is not to denigrate any of the vendors, it's not to denigrate any of the customers, but if all you do is limit yourself to the tool in your hand, that nail gets the hammer, that screw gets the hammer, and that wood eventually will chop with that hammer, but it ain't pretty when we get to the pane of glass, is it? So I think to your excellent point, it's about understanding the relevance to the business goals. And I think that if we proceed from that, and a little plug for Lenovo, that's how we roll. We want to understand what's relevant to the customer. We want to understand what their business goals and objectives are so that we can speak relevantly to that. We don't rush to, oh, an answer's a 5, here's your hammer. No. What is it you really want? What is it you really want to see?
The concerns that I have with AI, especially with nowadays, is what we just talked about, manipulations and of feelings and certain things. What's the ethics around it?
Oh, that's
So,
excellent.
in terms of ethics, is there any guidance in terms of it right now? I apologize for asking this question.
No, don't
No,
apologize.
Like there's a lot of companies right now that are talking about responsible AI. There's certain regulations that are coming out. The US is way ahead of Canada in that sense, because we're trying to, in Canada, we're trying to pass a bill that's related to cybersecurity, and then we kind of just threw in AI.
By the way.
Yeah. And so I think the US has state-specific regulations. I know a lot of European organizations are a lot more forward with that. The OSCE has been working on this for a while as well, but yeah, it's kind of up in the air and everyone's still reacting right now, right? There's a few that are coming out and they will start coming out even more. And even, I think there was the bill that, the act for AI that Biden was pushing, that is now gonna be changed over, just because he had quoted that it's just gonna impinge on any type of innovation that's gonna happen. So it's interesting that we're talking about ethics, but then ethics versus innovation is a conversation that we're happening. It doesn't necessarily have to be a separation.
Agree.
So, when it comes to this topic, right, one of the things I want to think about is when printer was invented, the first time we invented printing, right, the biggest challenge that people had was this. Now everyone can print. Now I can print everything and everyone will believe it because it's printed. And it's true, right?
Got it right from Mr. Gutenberg.
Right? And just like it looks like printed. Now I can print lies and everyone will believe it because it's printed. But today no one believes if something is printed, that it's like true, right? And I think the same thing gonna happen very soon. We have lots of this Gen AI thing that we have. We're gonna stop believing them because there is a transition time that we keep believing everything because we haven't seen it. But at some point we're gonna quickly. I remember 20 years ago, and maybe 25, 30 years ago. I'm getting too old. Numbers. When computers came out at the very, very beginning, I remember I showed something to someone on a computer. They couldn't believe what they see that. They think it's like a TV, and whatever it says there, it is true, right? And I would see my own eyes, people looking, oh, it is on the screen, it's true. But now no one believes that, right? So I think the same thing that happened for all these general things. Like very soon, people are not going to believe anything, like in any video, right? But there's a transition period, which is very important to be mindful about that transition period of to safely pass it.
It's interesting. I think that it's quite possible that over time will evolve a need to cite sources and some sort of a standardized rating of believability. Okay? And then again, ultimately, opinions and what we understand together is somewhat subjective. We love it to be objective. But quite often, it's the intersection between what we can prove and what we can't prove. So I think it's entirely reasonable to speculate on almost a rubric of accuracy. Okay, and I think I love what Joe said about the fact that after they found out it was generated, they still didn't care because it could happen. That's scary. That's not
exactly. I mean, with all this happening, and you're talking about essentially believability, right?
Yes.
As a measure, but to the society, does it matter? Even if you fact check it, and you saying that this is correct, and whichever, and yeah, all these references, doesn't matter, right? Doesn't matter in terms of the public, the perception, the view, doesn't really matter. So that's a question that, is for the public, right? For the future.
I mean, there's a lot about like how our realities are changing and like how technology is helping that. Because even now, if you folks have heard about Google's new quantum chip, Willow,
Indeed.
that was cited as a very big change. Because the problem that we've had with quantum for the longest time is maintaining quantum coherence. So there's always going to be error rates when you're trying to scale up, because you need to have a very stable state.
Coherence loss.
Yeah, exactly. But like with this new chip now that got released like a couple of days ago, what Google is able to do is they're saying as they scale, there's actually a reduction in errors. So that's really changing like the way that we can use these tools, and it's going to proliferate a lot faster than we thought. And they were also talking about potentially multiple realities. It was in their blog, so I was like, okay, you're priming people for like a new reality is what we're talking about.
And it's very interesting that you bring that up because, when we talk about quantum computing and what is going to be the next step, right? It's very scary too because we talk about, the advancements is great, but then we still have to talk about the cybersecurity, right?
Yes.
Of the current scenario. Right now, we have a RSA security is actually being broken by Shor's algorithm. So it's very scary in the near future that your data that's encrypted now could be broken later, right? In the next couple of years. It needs to be very much danger in terms of threat actors, right? In terms of what they're doing right now is something to keep in mind is the concept that they call store now, decrypt later, right? So they're basically storing all the data right now, and then in the future when it's possible to decrypt, then they can decrypt it and then basically analyze the data with AI.
Yeah.
So that's a very key and interesting point.
Oh, it's a very interesting point. I hate to say it, but I'd really like to find something that could scrape off all those little yellow stickies with some of these passwords stuck to their monitor. I'm looking for that moment too. But what you say is accurate. Our ability to hinder ourselves is almost as strong as our ability to enable ourselves. And that's the wrestling match, that and ethics, that we're going to have in perpetually. We don't wake up one morning and say, we're ethical, problem solved. We wake up this morning and say, just for today, we're going to do our best to do right for everyone else.
And that's a great way to finish off. I wanted to thank everyone on this panel for having a great discussion. I love that we can just kind of vibe off of each other. And thank you all for listening.
We have time for one question.
Yeah, go ahead.
Anyone
Go for
has
it.
a question? If not, you can reach out to.
Yeah, we'll be in the back just chatting, so feel free to come talk to us.
Yeah, this is not like your only window.
Yeah, for sure. Awesome. Thanks, everyone.
Thanks all.
Thank you.